Okay, welcome to some more fun with math. In this video, I'm going to talk about how to simplify rationals, how to multiply them together, and how to divide them. Now, a rational expression is essentially a glorified fraction. So the biggest thing that is going to come into play is going to be your fraction rules. Those fraction rules essentially being that your denominator cannot be 0. When we're trying to find the domain says the only thing we care about is the bottom. Okay, the top doesn't matter. So the part of the rational that we are simply looking at is just this bottom part here. So the x plus 3 does not matter. And what we have to do is we essentially have to solve it. So we have x squared minus x minus 6 equals 0, because we are looking for the values that would give me a 0 here on the bottom. And so since we know that this can't equal 0, that's essentially what we're solving for. So here I could factor this down. So x squared breaks into x and x. My sign here is negative, so it means one positive, one negative. And I need factors of 6 that give me 1 as an answer. So my factors of 6 that give me this negative 1 here are going to be a combination of 3 and 2. Since I want my b term to be negative, it means the bigger factor is negative. So I have a positive 2 and a negative 3. Then I need to solve. So x plus 2 can't be 0, and x minus 3 can't be 0. So x can't be negative 2, and x can't be 3. So when we're talking about a domain, we have two ways that you can essentially write it. The first way is called interval notation. Interval notation says my domain is going to be from my smallest up to my factor, from my factor to the next factor, and from that factor to the largest. So we have negative infinity up to negative 2. We're going to union this from negative 2 to 3, and union it from 3 to my positive infinity. So when we're looking at these, the way that you know that you say have hit all of your intervals is however many solutions you have, you should have one more interval in your domain list. So here I had 2 solutions, so I had to have 3 intervals. The other way that you could write this is in what's called it's a notation. And so here you have that D is, you're going to open yourself a bracket, and we're going to say x such that x can't be negative 2 or 3, and we're going to close it. So this is a subset. So essentially what we're talking about is subset notation. And so that would be the second way you could use it. Most of the times interval notation is what most instructors look for, but you can do it in both ways. And if we're just simply asking you for the domain, this is what we're asking you to do. Now another thing that we can do with rationals is we could do what's called simplify. Simplify, multiply, or divide. So simplify means you want to take a big, hairy, scary fraction or rational and you want to reduce it down as far as it can go. Now we're going to do that through the use of factoring. So you're going to factor the top and factor the bottom, and what your hope is that you're able to cancel. So in this instance, we have across the top, I have 6n squared plus 6n minus 72. So the first thing you want to look at is, can I pull 6 out of 72? And the answer is you can. So I'm going to pull a 6 out, which leaves behind n squared plus n minus 12. Well, I still have to factor this down, so I still have this 6, and I'm going to factor it into its pieces. And so here, this becomes an n and an n. My last term is negative, so again I have one positive, one negative, and factors of 12 that give me 1 are going to be 3 and 4. Since my b term is positive, the bigger factor is positive, so this is plus 4 minus 3. And that, for the moment, is what we're looking for. So this piece here is what we need. Now the other one we have was 3n squared plus a 6n minus 45. So again, I already know that I can pull a 3 out of 6, but I would double check if you can pull a 3 out of 45, and you can. So you're going to pull the 3 out, and it's going to leave behind an n squared plus a 2n minus 15. And so in this case, my 3 is still long, but I need to go ahead and factor. This is going to become n and n. My back term is negative, so this is one positive, one negative. And I need factors of 15 that give me a 2. Well, my factors of 15 will be 3 and 5. Again, since my middle term is positive, the bigger factor is positive. So this is 5 and negative 3. Again, this is the piece that I want. So since I have reduced the top and bottom down to their factors, I need to rewrite my rational. So my 6n squared was on top, so my rational becomes 6 times n plus 4 times n minus 3. And this is going to be over the bottom, which was 3 times n plus 5 times n minus 3. And now what you want to do is you want to reduce or cancel your like terms. So here I know 6 and 3 reduce. 3 becomes a 1, the 6 becomes a 2. I also know that I have n minus 3 on top and n minus 3 on the bottom, so those can cancel and go away, which is going to leave me with 2 times n plus 4 all over n plus 5. So that would be as far as you need to go. Now in some cases, when they simplify, they want you to distribute things back through, so it's really going to come down to kind of the instructor that you have or the problem that you're facing. If you have to factor it through, then this would become 2n plus 8 over n plus 5. But really both of these two answers here say the exact same thing. Okay, and so this would be simplifying. Multiplying is the exact same thing as simplifying. The only difference is once you simplify as far as you can go, then you have to do your multiplication step. So remember, when we're talking about multiplying with fractions, we talk about that you multiply straight across the top and across the bottom. Okay? But in order to get there, first you have to simplify. So we have 4 different reductions that we have to make here. So we can start with the first one. So I have n cubed plus 2n squared. So when I simplify that down, the first thing I can do is I can pull out an n squared. So when I pull out n squared, I am left with n plus 2 behind. Underneath it, I have n squared minus 4. So here I can factor this into its pieces, which is going to be n plus 2 and n minus 2. I also have n squared minus 5n plus 6. Again, I need to factor this into its pieces. N breaks to n and n. My back term here is positive, so that means I have 2 possibilities. Positive times positive, which gives you a positive result, and negative times negative, which gives you a positive result. Again, what you need, excuse me, what you need to remember is that this side of the equal sign is your C sign, and this part over here is your B sign. So here, my back term is positive, but my middle term is negative. So the only way to get to that would be if my 2 factors here were negative. So this becomes a negative and a negative. And then I need factors of 6 that are going to give me a 5. So the only 2 factors that are going to do that would be 2 and 3. And then the last thing I have is I have 4n cubed minus 16n squared minus 48n. So here, when I look at this, I know that I can pull a 4 out, and I also know that I can pull an n out. So now I have to look at what's left. If I pull a 4n out of my first term, it leaves me with an n squared. Pull a 4 out of my second term, it leaves me with a negative 4n. Pull a 4 out of my 48, and it leaves me with 12. Pull the n out, so I just have the minus 12 here. I have to reduce this down further, so the 4n comes along, but then I need to factor it. I'm factoring right here. So this is going to break into n and n. My last term is negative, so 1 positive, 1 negative. I need factors of 12. That will give me a negative 4. The only combination that will do that is 6 and 2. Because my last term is negative, it means the bigger positive is, or the bigger factor is negative. So this is positive 2, negative 4. Nope, negative 6. Sorry about that. And so now I have all of my factors. So I have to take what I just did here and I have to plug it back in so that I can look and see if anything cancels. So my first term here, n cubed plus 2n squared, became this factor. So this is on top. So I have n squared times n plus 2. And this is going to be over the second factor. So the n squared minus 4 broke down like this. So I have n plus 2, and I have n minus 2. I am still multiplying. N squared minus 5n, so the third term here, which is these two, goes on top. So this is n minus 2 times n minus 3. And then the last but not least, this one over here goes on the bottom. 4n times n plus 2 times n minus 6. So with this, I have to start figuring out which ones can cancel. So the first thing that I can notice is that in terms of top to bottom, I've got a pretty good top to bottom one right here, which says that I can cross those out. So the +2 and +2 goes away. Therefore, if I look at it, what I have left is as follows. I have an n squared on top over the n minus 2 times my other fraction. So this is going to be n minus 2 times n minus 3 all over 4n n plus 2 times n minus 6. Now the other thing that you can notice is, again, top to bottom, I have this n minus 2 and n minus 2. And so those can go away because I have one on top and one on the bottom, thus leaving me with n squared times n minus 3 all over my 4n times n plus 2 times n minus 6. The last thing I have that I can look at is I have this n squared and I have an n. So I can reduce these. So both of these will change. This becomes a 1 and my n squared becomes an n, thus giving me the reduced form of n times n minus 3 all over 4 times n plus 2 times n minus 6. And if you look at it, there is nothing else here that is the same. There is nothing else that can actually be reduced. So therefore, this is as far as you would go. And this would be your end result. So that is multiplication. Now, when we look at division, we have to remember multiply by the reciprocal of the second fraction. What that means is I have to multiply, so the first thing that has to happen is that this has to change. So the problem I'm actually working on is going to be 2n squared plus 5n minus 12 all over 5n squared minus 20n times n squared minus 16 all over 20n squared minus 30n. Now that I have everything in the proper order, I can actually get to work in trying to reduce each of these. So I have 2n squared plus 5n minus 12. And I need to be able to reduce that down. So when I do that, I can factor it into its parts. This is going to be a 2n and an n. My back term is negative, so I have one positive, one negative. And I need factors of 12 that when combined with my 2 give me 5 as a result. So if I'm looking at my factors of 12, I'm looking at 1 and 12, I'm looking at 2 and 6, and I'm looking at 3 and 4. So I need my factors of 12 that are going to be able to do that. So remember, in order to get the middle term, we're looking at outer times inner. So 2 times something plus or minus something has to give us 5. So if I'm looking at 1 and 12, my instincts would be telling me that's not going to work. Because if I have 2n times 1 and then minus 12, that's too big. 2n times negative 1 plus 12 is still too big. And if I multiplied it by 12, that would be too big. So this one can't work. So I'm down to 2 and 6 and 3 and 4. So I need to get to 5 here. So the one that I would be leaning towards is 3 and 4. And let me tell you why. 2 times 4 is 8, minus 3 gives me 5. In order to make that happen means I have to have a plus 4, and it means I have to have a minus 3. 2 times 4 is 8, minus 3 is a plus 5. Now, I also have 5n squared minus 20n, which is going to reduce to being a 5n on the outside and an n minus 4 on the inside. I then have n squared minus 16, which is going to become n plus 4 times n minus 4. And then last I have 20n squared minus 30n, which is going to give me a 10n on the outside and a 2n minus 3 on the inside. So that being said, I can actually put everything back together. And so just like we did before, we're going to put them back where they belong. So we have 2n minus 3 times my n plus 4 goes on top, divided by my 5n times n minus 4. I am multiplying this by the n plus 4 times n minus 4 over 10n times the 2n minus 3. So the first thing that I would look at is the fact that I have this n minus 4 and an n minus 4. So these I can cross out and they'll completely go away. The second thing that I have is I have this n plus or 2n minus 3 and a 2n minus 3, which also says I can cross them out and they will completely go away. This is going to leave me with n plus 4 times n plus 4, and the whole thing is going to be over 5n times 10n. Now, since there's really not a whole lot left to be able to reduce, there's a couple ways that you can write this answer. First, you can write it as n plus 4 times n plus 4 all over 50n squared. Or you can write it as n plus 4 squared over 50n squared. Either way, it's the exact same answer, but after all, at the end of the day, one of these is exactly what we were looking for. And thus, you have done your division. Okay. The last one that I wanted to look at real quick is a fraction on fraction one. And this one is really important because first you have to use your add, subtract fraction rules. And then the second thing you have to use is you have to use your division rule. Then the third thing you have to do is simplify. And state your result. Okay. So the add subtract rule says that you have to have a common denominator in order to add or subtract. So we have to look at these as two separate entities. The first thing that I have is I have 3 over x plus x over 3. So in this case, my least common denominator is going to be a 3x. If I look at my first term, I have an x in the bottom, but I'm missing the 3. So this becomes 3 times 3 all over 3x. And I'm adding this to the second term. I have the 3, but I'm missing the x. So this becomes x times x all over 3x. Your rules say do the math. So this is 9 plus x squared all over a 3x. Now I need to look at the bottom. The bottom says I have 2 minus 1 over x. And the biggest thing that you have to remember is that any whole number is the same as that number over 1. So the least common denominator here is going to be x. If I look at my first fraction, that's exactly what I'm missing. So this becomes a 2x over x minus. In my second fraction, I've got the x on the bottom, so this is just 1 over x. And then, of course, the rules say write it as one fraction. So 2x minus 1 all over x. I now have to rewrite them into my division form, which says that I have 9 plus x squared over my 3x. And then in this case, I am dividing that by the other. 2x minus 1 over x. Again, my division says I'm going to keep the top, change the sign, and flip the reciprocal. So this is going to end up becoming 9 plus x squared all over a 3x times, flip the reciprocal, x over 2x minus 1. In this case, we want to be able to reduce, and so notice I have an x on the bottom and an x on the bottom. And so I'm going to go ahead and remove these, which tells me that the only thing that I have left is that I have 9 plus x squared on top and 3 times 2x minus 1 on the bottom, which can also be written as 9 plus x squared over 6x minus 3. Either one of these would suffice as a final answer. Since there's nothing else you can do, you're completely done and have reached the bottom. So that, in a nutshell, is everything you would need to know to start being able to work on simplifying, multiplying, and dividing rational expressions. Remember that you need to use your basic fraction rules. So if you have any questions, please let me know. Otherwise, keep smiling. Have tons of fun with your math. Be sure to relax. And as always, I'll see you next time.